So I think everyone are familiar with creating a smart contract, creating the MetaMask, and transactions stored in Ganesh blockchain, right? Okay, so meanwhile, has given the feedback from first session, I think one professor who is from, I think one person who is from industry, he has given some instruction, right? So considering that instruction, I'll consider one architecture and demonstrate, I'll explain how exactly smart contracts are working. Okay, so let me share the screen. That is the architecture that was used for my work. I'll just share and demonstrate and explain that how user interface, MetaMask, blockchain, and IPFS are related. I'll just so that you will get an idea. That's the only purpose here. Okay, let me share the screen. Okay, I hope this architecture diagram is visible to everyone.
Yes, sir, it's visible.
Yes, fine, that's fine. Okay, now, so from this architecture, what can you analyze? You can see one off blockchain part, one on blockchain part. In between, you have a MetaMask, then you have IPFS. Okay, so let me discuss about IPFS here. You know that whenever any transaction is happening in the Ethereum blockchain, it consumes gas, right? So when I have a larger data, gas transaction fees is depending on your data size also. Okay, so whenever I have some larger data to be transacted, then it consumes more gas. To overcome this drawback of higher gas fees, you have the technology which is decentralized database, I can say IPFS, interplanetary file system. Okay, so one or other day, I think this will become an alternate for HTTP protocol. That is what the suggestions that are given by the experts in this field. Interplanetary file system is a distributed database wherein any device, if it has some space to store the data, it can be part of that decentralized network. Suppose now, if I have some space in my device, right? So I can store some data, then I can be part of this interplanetary file system. Then some particular data can be stored in my device. So interplanetary file system works in a manner that if any user requests or sends the data, it can store the data, and in turn, it will give the hash value. Hash value representing the address of that data that is stored. Okay, so IPFS server, it in turn divides that entire data into pieces and it distributes that in different devices. Okay, now anyone who has that hash address can request for data, then IPFS, it will collect the data from different devices and it will give the data to the person who has requested the data. Okay, so my intention of using IPFS here is, now the work that I have done is generating the credit report. Okay, now if the size of the credit report increases, then I will store the data in the IPFS, then it will return the hash value, then I'll fetch this hash value and give an input to smart contract. Hash value size will be in terms of kilobits, wherein the data that I am storing in IPFS is in terms of gigabits. So I am getting a huge advantage here by using IPFS. Okay, so this is what the usage of IPFS. Okay, and so that you can avoid huge gas consumption, right? So by seeing this architecture of blockchain application layer, front-end framework and web3.js, now a user inputs the values through user interface, then that is fetched from web3.js, then that data is stored in IPFS. IPFS returns hash value, right? Now, this hash value is fed as an input to smart contract. To validate that smart contract, we are using MetaMask. Okay, so for all the transactions that are transacted in the network will not be stored in the blockchain. For example, consider double spending problem, right? As these deals with the digital currency, right? So there is a possibility that double spending occurs, right? So when one particular sender has transmitted the data, when it is not, the balance is not updated, there is possibility that, okay, the same currency can be reused for other purpose. Okay, this can be avoided in Ethereum blockchain double spending problem, because okay, so once the transaction is done and the transaction is verified, then only that transaction will be stored in the blockchain. So how will you verify? You know that the entire network will have a copy of the distributed ledger, that is blockchain. Anyone can verify that whether that particular person who has sent the transaction has the really he has the balance, or he is trying to double spend the currency. Okay, this can be avoided through this mechanism. Okay, so all the transactions only after verifying through the process of mining. I think in the morning session I have given you a link. I don't know whether anyone has gone through that or not, but it clearly gives indicates about the information about the what exactly you mean by mining. Mining uses proof of work or proof of stake. Okay, Ethereum is moving from proof of work to proof of stake, right? So here, mining is nothing but you have a kind of mathematical puzzle, right? And there are n number of companies who are working only dedicated on this mining. And a normal devices cannot be performed to mine. You require huge resources to mine that. And everything, the mining, manually it cannot be done, right? So you require huge resources to mine that. And after successful mining, right, that can be broadcasted to the network and anyone can verify that. Then after that only the transaction will be stored in the blockchain. Right? So in the previous cases, we were seeing that, right? Transaction 1 is recorded, transaction 2 is recorded. And for all the transactions, right, MetaMask is giving the confirmation. Okay. So in this architecture, right, all the inputs that are stored in IPFS return the hash value. Then this hash value is fed as an input to this smart contract, which is on Ethereum layer. Okay. So in the entire architecture, only the smart contracts and the transactions are stored in the blockchain, whereas this front-end part, Web3 part, IPFS, they are not stored in blockchain part. Is this clear? I hope some information is given here. Is that fine? Are you able to understand? Right? So you should understand how exactly blockchain works. Okay, so with this concept, let us start with the hands-on session, second session, right? So I'll give you 2 examples because I'm not here to teach the entire Solidity programming language, right? If you are familiar with C++ and Java, it is easy to understand the code. I'll give you 2 examples. You execute that and see if you have any doubts or if you are able to execute or not. Then I have an interesting 2 concepts. One is using user interface to get the data. Other one is vulnerabilities on smart contract. Because without knowing the vulnerabilities of smart contract, right? If you write a smart contract, then if your smart contract is vulnerable for various attacks, in real time, you cannot deploy those smart contracts. There is a tool, simulation tool called as OANT. Okay, a tool called as OANT, right? So you can use that, you can download the tool. Then you can test all the smart contracts that you have written, whether your smart contract is vulnerable for any of the attacks. Currently, right, I'm working on this OANT extension Okay, and you have n number of opportunities to work in this area also. There are various tools like Oyante, Smart Check, Mithil. These are all the tools which detects the vulnerability that exists in the smart contract. Because fine, if if it is for a research purpose, right, you can execute this in the Ganesh, fine, no problem. But if your smart contracts are involved in real time transactions, then I think you have seen the latest example, DAO attack, okay, which has led to loss of huge, I think $150 million. Okay, there was a bug in that smart contract, and some hacker identified that bug, and he has contradicted the smart contract, written the contract to overcome the, to take out, to what you call, to overcome that or to encash that bug in the smart contract. He has written a contract and he tried to, what you call, what are the ethers that are available in that contract, right? More than, it's a, I think $150 million, I think so. Okay, then some hackers itself identified that, right? Then they, at the end of the day, right, they themselves drained the ether, I mean wallet, so that they had, at the end of the day, that all the transactions were not succeeded and they were able to save that huge amount. Okay, that is what the importance of, what you call, vulnerabilities in smart contract. Without knowing vulnerability, what are the vulnerabilities in smart contract? Okay, so don't write smart contract for a bigger applications. Okay, so there was a question in the chat: why MetaMask require offline application? See, as you know that MetaMask is used to interact with the smart contract and it acts like a wallet. So wherein all the transactions are approved by MetaMask, then only those transactions are stored in Ganesh. That means blockchain. Okay, so you are not, what are the transactions that are stored, that are not stored in MetaMask, right? MetaMask is not an online, on blockchain. It is not stored in on blockchain. It is just a browser extension which acts like a wallet for all the transactions. You know that all the transactions should be verified. Only after verification only transaction will be stored in the blockchain, right? That's for the purpose, right? Now let me share the two programs in the chat. I'll share the program, execute that programs, okay, and see if you have any doubts. Then I'll move on to another important example. Then at the end, I'll discuss with the that vulnerabilities in smart contract. I pasted a program one. The same way, I'll paste a second program. These are all very simple programs. So some people have suggested that if you practice, it will be still good, right? So that's the reason that I'm giving you this program. Okay. So I given two programs. You just go through that programs, try to compile and execute that program. Okay, see the transaction, how transactions are stored in the Ganesh. Once that is done, then I'll move on to user interface example. Then I'll discuss the vulnerabilities. You can start executing those programs.
Hello. So your voice is not audible.
No,
Closer
no,
to
ma.
the
I gave examples to work, ma'am.
Oh, they are working.
Yeah. Yes, environment should be injected Web3 only because you are using a MetaMask and that transaction should be stored in Ganesh, right? Only if it doesn't have that database, I am getting unused parameter warning. In which program? First program, right? First program. Okay, just check with the constructor parameters. Try to remove that constructor parameters, madam. Try to remove the constructor parameters, unsigned int initial amount and unsigned int initial. Then check, madam. Yes, fine. Understand the program because it's a C++ and Java based. I don't think it is required to explain the program. Second program, same program will be using with the user interface. Okay, understand that program. Okay, next we'll see how to get the input from the user from localhost. Everyone able to do? Any participant has any kind of problem? Gas requirement of function name dot fetch name is infinite if the gas requirement of function is higher than the block gas limit. Please avoid this. You are getting this as an error, madam, Nishi Gupta, or warning? Compiled. Yeah, see, these are all warnings about gas limit. I see, if you go on executing this program for 100 times, obviously your gas will also exceed. Okay, your gas will right? You lose that gas limit also, right? So once you exceeds that, then you cannot compile. Even though it is a simulation, but it should work like a real time, right? Yeah. Yeah, in security I can, yes, yes, yes. Fine, fine, fine. No issues. So I'm just igniting blockchain knowledge here. Okay, so you need to explore. These are all very basic concepts. First, understanding blockchain concept is very, very important. How it works, what do you mean by transaction, how transaction is stored, what is mining, there are different types of mining, proof of work, proof of stake, what is the difference between all these mining methods. Okay, then after you theoretically understand the concepts, then you can come back to smart contract, because smart contracting is the area where you can implement. However good you are in theory, but at the end of the day, you have to implement and develop the any particular projects or research, right? So this is where the smart contracts will be useful. Anyone in having difficulty in executing that? So you ensure that whatever the transactions that are successful, they are stored in the blockchain, Ganesh. So Ethereum is considered the public blockchain. In contrast, you have private, pure private blockchain. There is Hyperledger. I think tomorrow you have a session on Hyperledger, hands-on session. Okay. So whatever requirement that you have to implement in a completely private blockchain, then you can choose Hyperledger. Hyperledger is that is developed by IBM company. Okay, so it is still under development, but still it is freely available. Anyone can use that Hyperledger. But Ethereum mainly public blockchain, right? And you know that it deals with the Ether, but that is not the case with Hyperledger. Hyperledger does not deal with any kind of Ethers, and I mean cryptocurrency. That's the difference between Hyperledger and Ethereum blockchain. And still, many you have plenty of opportunities to work on Ethereum blockchain. Okay, sir, if possible, please demonstrate all the steps for second program from compilation to deployment using MetaMask and Ganesh. Fine, sir, I'll do it. I'll do that. I'm just opening the Ganesh. display. Okay, fine. Now I have opened Ganesh. Know that it has 10 default accounts, right? You can change that also, right? Now we'll come back to the Remix Remix extension. Okay. Name. I think I have that program, my contract. Okay, this is the program, right? Okay. It is assigning the minus new deposit to value and amount is equal to amount plus new deposit. Okay, so one will go on. Okay, now we will try to compile this program. So compilation, Solidity compiler. See, there are different ways of compiling, executing that, right? So we'll compile that first. See, once you compile that program, why it is called as the Ethereum virtual machine? What is the functionality of Ethereum virtual machine? The program which is compiled that can run anywhere, right? So once the program is compiled, it will create a bytecode like this. You can see this bytecode here next to ABI. Below publish on Swarm, publish on IPFS, compilation details, ABI application binary interface, and bytecode. Okay, so bytecode is in terms of opcodes. I'll just paste that. See here, it is in terms of opcode. There are nearly 151 opcodes in Ethereum. Okay, and all the vulnerabilities that exist in the smart contracts, they are detected through this opcodes only. They function through this opcodes only. Okay, and you have application binary interface, right? So when the program is compiled, it will create an ABI and bytecode. These you can make use of this ABI and bytecode to run this smart contract. Okay, so application binary interface is nothing but entire smart contract code is written in terms of binary language. Okay, so you can see that what exactly the code you have written, and that is equivalent to this ABI in terms of ABI format. Okay, we will use this ABI format in the Web3 JavaScript program. Okay, now you have compiled the program. Now for deploying program, we have selected injected Web3. Okay, let me start MetaMask. Okay, let me import the address. Every time this is showing in. Okay, let me import the address. So every time it is converting to Kannada language. Okay, now I'll use the private key of any of these Ethereum. Okay, click on the showcase and select this private key. Copy this, then come MetaMask, paste that. Now you can. Okay, now you have got different accounts, right? And I have selected account 4, which is having 100 ethers, right? Now, okay, it is first considering that. Let me delete that other accounts. Just a minute. Not able to translate this. Okay. See, these accounts are, I think, previous sessions accounts. That is why it is giving an error here. Let me import one account now. Okay, right. Let me refresh this. So if you are having any problem, just try to reload the remix page. So let me use the now let us deploy. Compile, then you have deploy, creation of my contract pending. Now, now deployed. Now you got a contract here. Now send. I'll be sending 100 rupees. See, whichever the buttons that are given orange color, right? You have to. This has to be clicked. See, only when you click on the send button, transaction will happen. Send this. Now MetaMask has to authorize that. It is validating that. Then once you validate that, observe in the Ganesh, transactions are stored and blocks are mining. These are the blocks that are mined. Okay. Now come back to this. Then get amount 100. So what are the amount that are returned? That is amount. Then get balance 1000 minus 100, 900 is printed. Is that fine? Right? Okay, that's about. So in the same way, now second program. Now we will see the second program. Compile name dot solve, right? Then injected web3, yes, fine. Now we'll delete this. Deploy of name pending. Yes. Deployed. Now we go to this. This is what the contract address. Okay, come here. Now fetch name. See, anonymous. Constructor is initialized and it is printing anonymous, right? Now you write something. Blockchain. Write that. One more transaction occurred. Then validating the transaction. Now, fetch name. See, you can see the blockchain. Is that clear? Getting here? Is that clear with both the programs? Participants, is that fine? Any doubts? Okay, now let us see on program. Now see, this is what the bytecode. I think I have not entered this. Now you can see the bytecode, right? I've just pasted this in the chat box. You can see jump destination, call value, duplicate 1, is 0, push 1. These are all opcodes. So once the program is compiled, it will create a bytecode like this. That is available. Once you compile that, ABA and bytecode are available, right? So I have copied that. For the previous program, this is what the bytecode. Okay, so vulnerabilities, detecting the vulnerabilities is they are working based on this opcodes only. So there are nearly 150 opcodes in Ethereum. All these opcodes are presented in Ethereum base paper, right? Okay, so is that fine? Now we'll move on to another program. JavaScript. You read the input from the user, then deploy that, and that will be stored in the blockchain. Okay. So for that you should have a Node.js. Okay. So Node.js should be installed. So because the script program is written in JavaScript. So I have written an index.html file here, which is written in JavaScript. The output of this will be, it is creating a button, okay, and it is asking to write something on that screen. When you write the program that we use for this will be this previous name button, name program, right? So initially anonymous will be written, okay. Then once you execute this program, the output of this program will be one button will be there, one empty box will be there. You have to write that, then click on that, write. Then in the background, okay, this whatever the data that you have written, that is fed as an input to the smart contract. Then smart contract is executed. Then transaction is stored in the blockchain. Then when you click on that fetch, right? Then what are the name that you have written, that will be displayed. Okay. So let me not go in detail about the coding part here. So the script source is equal to web3.js program that I have taken from GitHub. Okay, I am giving the link. Okay, so script source is equal to https:/cdn.jsdeliver.net. So some input link I am giving here, okay, as a source, which is encoding for web3.js, right? Then variable contract, $document.ready function, web3 is equal to new web3 of web3.current provider. Okay, so web3 dot current provider. I think in the previous session we have seen the different environment, right? Java virtual machine, then injected web3, then web3 provider. Okay, so here web3 dot current provider, and it is asking the variable address. This variable address is nothing but the contract address, because user interface has to connect to that smart contract. Okay, so once you compile that, then you get that contract address, paste that contract address here, then variable application binary interface. This is what the ABI. For example, the program, once it is compiled, see here, you can see this ABI, right? I'll copy this and paste in the chat box. Okay, see the same API I copied there. This is what application binary interface. For every function that you have written in the smart contract, for that it is acting constant true inputs, name is equal to fetch name, outputs, name, type string, payable false, state mutability view, like this, right? So this is how for your smart contract code an application binary interface has been generated, right? And we are going to paste this in that JavaScript code from here. Okay, just a minute. I'm going to paste this API here. Done. Okay. Next, contract address. I'm going to copy the contract address. So contract address, once you deploy that contract address, okay, now see, you can see here name at 0x85x. I'm going to copy this contract address, program, okay, now you can see the contract address, right? Then after this ABI integrated, then contract new web3.eth.contract, you have ABI and address, you are giving that contract.options.from which account this contract is executed. So you have to give that account address, external account address. Now come back here. This is what the external account address. I'll copy this external account address, paste this here. Right? Next, contract.methods.fetchName.call.then function name. It is trying to fetch that name from the input. Okay, so these are all the Ethereum.on chain changed document.location.reload. So once you write the name, then it has to reload that. Then whatever the name that you have written, okay, it will be accepted, and that should be assigned to the account, whichever the account that you are for which account you are executing that particular program. Okay, this is a code. Now let me save this code. Right now, anyway, here in this terminal, I have opened this HTTP server. So HTTP server is running here. Install this Virtual Studio code in which I have this PowerShell window. So I am getting the terminal. How I am executing this HTTP server here. It is on. Right now, come back here. Now I'll try to run that host 8080. You can see that, right? When I run that localhost 8080, it is asking the name. Okay, so initially anonymous is printed. Now I'll write JavaScript. Then now observe the now, as soon as I click on write, MetaMask is active. See here, I have clicked on the button right, so MetaMask is acting to connect. Then I am connecting that. Okay, now in the program, right? So earlier blockchain was there. Now let me fetch that. I've written already the name. I'm trying to interact from input. Let me see. Just a minute. Then error not found. Okay. Okay, deploy. Right. Okay, it is reading here. So that localhost, it is not getting that. So it is giving some error here. Let me run server once again. I think it is not no error in the server part. Okay. See, all transactions are stored here, but it is not displaying there. Let me check now. X8560. Okay, I'll just share this code. Okay, so this is what the procedure. I'll share the working code. I don't know where where we went wrong. Okay, so this will demonstrate So you are creating a user interface. So in the local host, when you try to give the name, user name from the user interface, right, it will accept that name and it will print that name. That is happening. Okay. So here for the same program, this was the same program, Pragma Solidity, right? For this same program, instead of reading the input from here, we are trying to read the input from user interface. That worked actually. I'll send you that working code. Okay. So like that, you can have the user interface and you can connect with the through user from front end. You can connect with you can communicate with the contracts. Okay, that's about another example. Now moving on to the vulnerability part. So what exactly you mean by vulnerability? Okay, so is there any vulnerability in this particular smart contract? How to check that whether this smart contract is vulnerable? There is some tool. Okay, I'll just open that. Okay, the tool name called OA. I'll just give you that information. Okay, ONT is a tool. Okay, so there is a base paper is also there, making smart contracts smarter. This is what the base paper. So how exactly they are able to, and let me discuss what are the types of, how many vulnerabilities exist. Okay, so I'll just have a code here. I'll just open that link, which gives you about the majority of the vulnerabilities. More than 20 vulnerabilities exist as of now in Ethereum smart contract. Okay, so out of which only 8 vulnerabilities are currently they are able to detect that. Remaining are undetected. Okay, so you have a opportunity to work on this area and to consider some of the vulnerabilities, and you can work. You can contribute your code to this oriented tool so that other vulnerabilities will also able to detect that through this ONT. Okay, so now let me open that code. See here. So list of security vulnerabilities: integer arithmetic overflow, floating point arithmetic, re-entrancy attack, access control. Okay, then denial of service attack. Under this you have 4 different types: entropy illusion, privacy illusion, minor attacks. Like this, see, as of now 26 attacks exist. Okay, and as of now this particular oriented tool, it detects only this integer underflow, integer overflow, call stack depth attack, transaction ordering dependency, timestamp dependency, re-entrancy vulnerability, parity multisig bug. Right? So this is the enhanced oriented tool. This was a project done by one of my students at NIT Tirchi. Okay, they have added this, extended this 3 vulnerabilities, and it is not published yet. So I cannot discuss those vulnerabilities. Okay, so we will discuss simple vulnerability, for example, integer overflow. Right? So before that, let me discuss how exactly this vulnerability works. Now you have the input to that oriented tool will be smart contract. So you provide the smart contract, then these smart contracts are compiled. Once it is compiled, you know that bytecode is created, right? I hope my screen is visible, right, for everyone?
Yes, sir.
Yes, fine. That's fine. Okay. So now, see, the input for the tool will be Solidity compiler, smart contract. Then it compiles that program. It will create a bytecode. This bytecode, it is fed as an input to disassembler. What is the functionality of disassembler is from this bytecode to opcode. it will disassemble to opcodes. Then these opcodes, right? So they are fed to control flow graph builder. I think control flow graph you come across in compiler design, right? So for some suitable opcodes, it will create a control flow graph. Next, for the same input, if it is creating two or more control flow graph, then that indicates that there is some kind of vulnerability exists. So that is the reason that these opcodes, they are created like a control flow graph. They are fed to control flow graph builder. Then control flow graph, based on the control flow graph, right, it is fed to vulnerability detector. So here the base paper they are using Z3 solver. Z3 solver. Okay. So by using that Z3 solver, they are able to detect that. Okay. So here, once they detect that vulnerability, then they are printing, right? So this type of vulnerability exists in this smart contract, or the vulnerability does not exist. Like that, they will be printing on that output of that oriented tool. Okay, so new attacks are introduced. So if at all, if you want to work on new attacks, right? So again, the existing architecture remains same. Only thing is you have to consider the new attack. For example, uh, unexpected ether. Assume that unexpected ether. What is an unexpected ether? Certain contracts behave erroneously when their account contains ether. It is always possible to forcibly send ether to a contract. So when you are forcibly sending ether to a contract in the code, in the smart contract, then that is a vulnerable. Okay, so that type of vulnerable has to be caught using your code. So how you can work here is, so you have to know, you have to assume that now individually you have a smart contract. Okay, so work on the smart contract, you will get the bytecode. Then analyze that bytecode. What is the form of that bytecode? Then what will be the control flow graph for that particular bytecode? Okay, so based on that, because any smart contract which has this type of vulnerability will give you the same kind of opcodes. Okay, so based on that, you can analyze that what will be the form of opcodes, and if in your smart contract, if you come across that form of opcodes, then you can indicate that there is a vulnerability. See, vulnerability means there are no errors in the smart contract. An attacker for which of the smart contract which are vulnerable, he can attack. So to overcome that, you are able to find out whether the smart contract is having the vulnerability or not. If your smart contract is not having the vulnerability, then you can go ahead. Or if you are having the vulnerability, then you have to change that code in such a way that, so in the smart contract, vulnerability does not exist. Okay. For example, let us consider the simple integer overflow attack. Okay. Now I think now, so shall I demonstrate that oriented tool? Do you want me to demonstrate that oriented tool? The output of that oriented tool? Can I get the answer? Okay. So if I need to demonstrate that, then I have to shift on to Ubuntu. So give me just 2 minutes of time. I'll shift to Ubuntu, then I'll log in from there, then I'll demonstrate that Ubuntu. Is that fine? Okay. Madam, Bhargavi ma'am,
Yes, sir. That's
I'll
fine,
just,
sir.
I'll log into Ubuntu, log into from Ubuntu ma'am.
Yes, sir. Sure.
Yeah. Okay, fine. Welcome back. Okay, so let me just give you that demonstration. So there is a link, right? I'll share you that link. So in which some of my students, they have written the article in Medium. Okay, so I'll just open that. So there was some major problems to just share. Is my screen visible, ma'am?
Yes, sir.
Okay. Now, see, I'll just paste this link also. So earlier, so when I started working at that time, so we are unable to download this file. Okay. So enter ONT. So for that purpose, so some of my students from NIT Tirchi, so they have developed this article. So once you go through this article, okay, step-by-step procedure is given how to download that ONT tool, then execute that lay. Okay, so I'll share that link here. This is a link. Okay, step-by-step procedure is given how to download the ONT tool. Okay, now let us start. So according to this will be the output. Output will look like this. We'll just go through that. So there are two ways of installing. One with the Docker, other with the by installing the entire ONT. Okay. So if you want to modify the existing code, see existing code for ONT is available in GitHub, right? So you can download that code. You need to understand that I have that code also. If you want, I'll show you that code. Entire code is also there. See, these are all the folders that I have downloaded from GitHub. Okay, main file is simexe.py. Let us not go through that. This is what the around 2,200 lines of code, existing codes are there. If you want to contribute, you can contribute this to this GitHub tool for any kind of vulnerability. Okay, so let us not go that in detail now. So we'll start, I'll just execute some of the programs. Okay, wait, just wait. So if I demonstrate this, then you'll get an idea so that you can work on that. This is what the link. Melon project. No, just a minute, just a minute. I think, okay. So you have to log in as super user to download that. will take time, but telecast, let me show the demonstration. Okay, done. I think you can see that, right? Downloading is happening. It will get over anyway. Because this is the only procedure, right? If you want to download using Docker, but you can download the entire ONT, but it is a very tedious task. Okay, it takes time. Okay, step by step you have to concentrate. Okay, so Python, there are so many prerequisites for that, right? So if you want to know whether my smart contract contains any vulnerabilities or not, this is the best method. Or if you want to contribute, then with the help of this Docker, it is not possible. You have to install ONT tool itself, then only you can contribute that. Contribute to the existing code. Okay, so reported. Okay, fine. Next step. So let us add sudo for this. Okay, so we are done almost. Almost we are done. Now we have installed the Docker, right? Now, so let me, there is one existing file, greeter.sol. Okay, so we'll try to execute that file. So what the syntax to run this is, pointer.py -s greeter.sol. Okay, fine. Now, see, now in the Docker, this greeter.solidity file exists. Okay, so for that file, I have given the input as greeter.sol solidity file. Now it is printing the output. You can see this results: EVM code coverage 99.5%, integer underflow false. That means wherever you have false, that indicates that there are no such vulnerabilities in that particular smart contract. Integer underflow, integer overflow, parity, timestamp dependency, reentrancy, transaction ordering dependence, reentrancy vulnerability. Because of this vulnerability only, you had that DAO attack. Okay. Now I'll create one file which has some kind of vulnerability and check that. Okay. So let me create that. I already have that. I'll just check that. Now, see here, pragma solidity, contract additive inverse, function negative. So if A plus C greater than A is equal to A plus C, return A. Now, this will give an integer overflow. I'll tell you why. See, integer can store only maximum 255 bytes. If the size is above that 255, then automatically it will round it off to 0. For example, assume that your two-wheeler reader odometer or car odometer maximum, assume that maximum 99,999. Once it cross, instead of 1 lakh, it is rounded, it is changed to 0, right? In the same way, with reference to smart contract solidity programming language, integer can be, the range of integer is 0 to 2 power 8 minus 1. Okay, so if the above integer value if you use, then if you have such type of codes, it will give an integer overflow. Now I'll try to find out that whether this particular solidity programming code has vulnerability or not. Right now, let me create this. So I'll create a file. First .sol. I'll create that file and paste that file here. Paste that code here. Paste. Then I'll save that. Control D. Okay, I've saved this now. This first .solidity file, it will be saved now in this Docker. Now we have to check that whether there is any vulnerability in this file or not. So what is the code to check that? So I'll just change this. FIRST first dot sol. See here, you can see the output, right? Integer overflow is true, and it is giving if a plus c integer overflow occurs if a is equal to 1 and c is equal to this range. That means your code is vulnerable if the C value becomes this range, right? So when you write a smart contract, you have to ensure that you don't write a contract in this way. Are you able to understand this? Yes. Am I clear? Yes, participants, are you able to understand this? I just showed the small demo, right? So there is a lot of research opportunity in this area. I mean, in this currently vulnerabilities field. Still, right? Every month, new vulnerability is added because entire smart contracts deals with real-time ethers. If you write a smart contract which has some kind of vulnerability, then you're going to lose ethers. So for that purpose, right, a hard research is going on this area. Okay, so I am also currently working in this. So I just start off giving you inputs about this so that you can explore in the future. If you are interested, you can explore. And currently 2 BTech projects are also going on under me with the same concept, right? So that's about this oriented tool. Okay, so like this, for all kinds of vulnerability, if you have any smart contracts, right? So you can check that. You can download this oriented tool. This was the link medium, right? So step-by-step procedure is given, right? You can download that. Okay, so once you download that, you can contribute the code to that existing oriented tool. Is that fine? Any doubts? Yes. If anyone has any kind of doubts, I'll share you all the links and all the resources by the end of the day. Okay, so there are many resources which provides you step-by-step procedure to execute that smart contract, MetaMask, Ganesh, and this OINT also. Okay, I'll give you all the links. Only thing is, whatever you have learned today, you have to explore until and unless, right? So attending this workshop will be definitely, it will not be useful. Can you tell about Docker container? See, like how you have a Docker, right? So it's going to pull this Docker container, which has that exe file of that OINT. Okay, so many researchers felt that downloading that OINT and working on that OINT is a bit difficult. For that purpose, right, they have created Docker content for this OINT tool. Okay, so using that Docker, you need not install the entire OINT. If you just download the Docker and you can work on that, only thing is you have to create a file and in the Docker itself. If the file solidity file is not stored in the Docker, then it will not display the output. Getting here? Okay, you have to create, as like I told you that, right? So create, you can use the cat command first.sol, write the command code here, then save that, then you can check whether any vulnerability exists for the tool or not. Getting here? Okay. Yes. Any other information? Sir, any other alternative tool available apart from OINT? Yes. I'll give you that link. Just wait. URLs. I think smart check, Mithil. So I'll just share this entire link. Okay, you just go through that. I'll mail you this also, but meanwhile, I'll share this in the chat. See, there are many tools are there, and at the end of the day, they are comparing that their tool with the existing tool. So obviously, when you want to introduce your own tool, that should be efficient to the existing one. Okay, smart check, OINT, Mytril, like this, many tools are there. Okay, I have given the list of URLs. Okay, just go through that. I'll mail you this also. As of now, I just sent that. Okay, just go through that. What are the resources that I have utilized? Because when I was doing this, many of the resources were not available. Okay, I have collected many resources. All the resources I'm going to share that, including the what all information that I have. Okay, definitely before the end of the day. Okay, I'll share this with the organizer, right? Or else if you have any mail ID, okay, my mail ID is this is what my unofficial mail ID. You can mail to me. Okay, I'll respond to that also. So I've just ignited the concepts here, but I request you to explore. Until unless you explore and work on that, right? So entire resources will be wasted. Okay, so you give the some kind of problem definition to the students. They'll be more eager to work on this, right? So currently 2 projects are under me with reference to this point only. They have identified some vulnerabilities and they are working on that. Okay, so with this I'll just wind up here. So let me go for question and answer session if anyone has any kind of questions.
Sir, I think there are no more questions.
Yes, participants, any more questions? Fine, ma'am. I'll share you all the resources, ma'am. Kindly forward that to all the participants, ma'am.
Yes, sir. We have a Google Classroom as well as a WhatsApp group where I can share all the methods.
Okay, if you add me to Google Classroom, I can share there.
Yeah. Yes, sir.
Yeah. Fine. Okay. Thank you on for all the participants, and thank you for Bhargavi ma'am, Asha ma'am, Emavati ma'am, and the entire BIT management for providing an opportunity to present the concept that I have learned past from 3 years. Right? It's a great pleasure to share the knowledge with all my fellow colleagues, faculties, right? So that they in turn, they can share this knowledge to their students. Okay. So definitely next 10 years, blockchain is going to rule the industry, right? And currently now we can see artificial intelligence and machine learning branches are opening. Probably next 2 or 3 years, definitely blockchain branch will be opened. Okay. So there's a next 10 to 15 years, you have a good opportunity to work on this blockchain field. Okay. I expect that all the participants will involve in one or other projects. Right? Thank you, everyone. Thank you, ma'am.
Request from one participant to unmute. Can I do so now?
Yeah, please, ma'am. Please, please.
Yeah. Purnima Girish Naik.
Yes, anyone wants to interact with me?
Okay.
Yes, Purnima Girish Nayak.
You can unmute yourself, ma'am.
Madam, please unmute yourself and you can interact with me.
Yeah. Now, am I audible?
Yeah, ma'am. Yeah.
So, in the case of that vulnerabilities, I wanted to ask, sir, if some vulnerabilities are detected, so how to fix that code? Any like in cybersecurity, we have the exploits and this. So, if vulnerabilities are integer overflow, how to fix them?
Solidity does not provide any way to detect the errors or vulnerabilities in smart contract. Okay, so it can indicate through this oriented tool that there is a vulnerability. See, vulnerability is not an error. You are vulnerable.
Weakness. Yeah, that is a weakness.
Weakness. So you are see, there is no way, right? So you should understand that there is a weakness in the code and you have to give the solution for that.
Yeah. Okay.
It is the responsibility of the programmer to ensure that so that particular vulnerability does not exist in the Solidity code.
Okay. So that is one question. Another question is, so you used the remix, then MetaMask and all these. So that was for one node, no? Suppose we want to test this for multiple nodes. like when all verify, like
Yeah.
these blocks will be replicated on each node.
Yes,
And
ma'am.
when all verify, like that block will be, that transaction will be added to the block. So
Definitely.
if you want to extend this further to multiple nodes, like
Yes.
can it be simulated on a standalone
Definitely.
machine?
We have past 1 year, 1 to 2 years, there are many simulators that have come out. For example, sim block. I'll give you that information also. I'll send you that information. Sim block is one simulator, okay, which will simulate for n number of nodes.
Yes.
Like this, you have many simulators, ma'am. I'll give you all those details also. With the
Yeah, if we do that,
base
we get
paper.
the real feeling of how the blockchain works.
Yes,
And
yes, yes, yes.
okay, sir. Thank you very much.
Sir, can you suggest any project apart from vulnerability check for smart contracts? Yes. See, Ethereum gives an opportunity to develop decentralized application, which is called as DApps. Okay. So leaving out that vulnerability part, you can develop decentralized applications in Ethereum. If you just Google DApps, DAPP in Ethereum, you get n number of DApps that are already developed. Like that, you can develop your own DApp for any of the applications. Okay, the way of creating is you have to use the user interface. Okay, then write the smart contract, then use any of these Ganesh to store that, and like that you can develop your own DApps. That's the answer for Dr. Girija. Any other questions?
Moving this side, Professor, I think it is a very good session. I pasted some of the 30 tools similar to INTA tools that were available actually.
Okay, okay.
I think I got around 30 tools, which is available along with their source code in the. So I took it from one of the research paper. I think the tool, this is very neat for the industry, where even for the auditing, because auditing the blockchain is a big challenge now.
Yes, sir. Yes, yes.
Okay. So the auditor also will use this tool.
Yeah, yeah, yeah.
So
Yes,
it will be very.
I'm telling you, sir, next 10 to 15 years, you have a great opportunity to work in this area.
Yeah, sure. Thank you very much. I'll be in touch with you, Doctor.
Yeah. Thank you, sir. Thank you. Any other queries? Okay. Bhargavi, ma'am, I think we can wind up, ma'am.
Yes, sir. Sir, I thank Mr. Lohith Zede for giving a very wonderful, interactive, hands-on session on Ethereum smart contracts. Usually, handling a hands-on session, that too in an online mode, is a very difficult task. So you did a splendid job over there, sir. Thank you very much for getting associated with this FTP and sharing your valuable knowledge on Ethereum smart contracts. So we look forward to some more of your talks.
Definitely, ma'am. I'm always there to share my knowledge.
Yes, sir.
Right. Thank you for giving me an opportunity.
Thank you.
Yeah.
Thank you, sir. Thank you. Thank you. Thank you, participants. We'll meet tomorrow for a hands-on session.